In this training byte, we will set timing budgets and analysis options for the topology that we had created in the previous training bytes. As always, for more detailed instructions, please go to support.cadence.com, where you can access the lab and training course that will guide you through the Security Topology Workbench tool with System SI for parallel bus and serial link analysis. Start by clicking on the Set Timing Budget option under Simulation Setup. On the right tab, change the data rate to 2.4 Gbps. Note that changing the data rate will automatically change the clock period, bit period and default strobe offset values. Next, change the minimum transmit setup and minimum transmit hold values to 0.4 UI. Change the minimum receive setup and minimum receive hold values to 0.3 UI. Now click on the Read tab and enter 0.25 UI in the minimum receive setup and minimum receive hold fields, and enter 0.4 UI in the maximum receiver skew plus and minus fields. Ensure that the TDQ-SQ value is 0.17 UI, and the TQH value is 0.74 UI. We will now set the proper analysis options for simulating the DDR4 interface of our simple parallel bus. In this case, we are going to do a circuit simulation of this DDR4 interface. First, ensure that the Use Channel Simulator checkbox is not checked. Next, click on the Set Analysis options under Simulation Setup. Under the Circuit Simulation tab, click on the Custom Radio button for simulation name. This will prompt every simulation to ask for a user-defined simulation name, which will help to keep all the simulation results organized. Under the Bus Simulation tab, ensure that the data write is selected. Next, under the I/O Models and Stimulus tab, ensure that the data rate is 2.4 Gbps, which was defined earlier. Enter 64 in the minimum number of bits field. We will now define stimulus patterns for the data and strobe signals. In the Controller tab of the I/O Models and Stimulus option, right-click on the first cell under the Stimulus Pattern column and select Define Pattern from the pop-up menu. Select Random as the data pattern from the pull-down menu. Since the strobe is a differential signal, ensure that their data patterns are inverses of each other. Also ensure that the stimulus offset is set to default. To assign I/O models for the controller, click on the edge of the cell of any data signal in the Transmit I/O Model column. Select DDR4_DQ34N48P_NO_ODT from the drop-down menu. Similarly, select the DDR4_DQS34N48P_NO_ODT for the strobe nets. To assign I/O models to the memory, click on the Memory tab first, and then repeat the process. We will be using the DDR4_DQ34N48P_ODT for the data signals, and the DDR4_DQS34N48P_ODT for the strobe signal. Lastly, we will set up a parameter for the simulation to sweep through. We will be sweeping the propagation delay parameter, defined in the tuning block of our topology. Click on Tools, and then click on Sweep Manager. Select Spice Models from the pull-down menu for parameter type. Click on the Parameter Radio button. Lastly, ensure that the tuning block is selected from the block pull-down menu. Double-click on Prop_data in the parameter column. Scroll right to find the Sweep List section and click at the edge of the cell in the Value List column. Enter 300p, 500p and 700p. Click outside the cell, and notice that in the Sweep Manager, there are now 3 iterations that will happen. This concludes the setup of the timing and analysis options of the blocks in our topology. Please refer to the additional training bytes in this channel to continue learning about the Security Topology Workbench tool with System SI.